Hi everyone, and welcome back to our course in college algebra. In our last couple of videos, we discussed the method of graphing using transformations. And in this video, we are going to continue our work with graphing, but we're going to talk about taking advantage of symmetry to draw graphs. So we've seen a few graphs that are symmetric, okay? A couple of our basic functions are symmetric, okay? So here's the graph of y equals x squared, right? And this function, as we know, goes through 0, 0, 1, 1 is on the graph here, right there. 2, 4 is on the graph. These are kind of our anchor points. So the right-hand side over here is the mirror image of the left-hand side. So 1, 1 is on the graph, and so is negative 1, 1. 2, 4 is on the graph, and so is negative 2, 4. So it's like with this graph, if you plot your anchor points on the right-hand side, you automatically get a corresponding anchor point on the left-hand side. 3, 9 is on the graph, and so is negative 3, negative 9, or negative 3, 9. Okay, so you change the x-coordinate and you keep the y-coordinate the same. So this is a graph that we would say has y-axis symmetry. The left-hand side and the right-hand side are mirror images of each other. Let me put another one up here. Let me do this one. Let's do x power 4 minus 4x squared. You notice this graph is also symmetric with respect to the y-axis. It's also got that y-axis symmetry where the right-hand side and the left-hand side are mirror images of each other. So if you were graphing this function, and you plotted points on the right-hand side, you automatically get points on the left-hand side. Now, let me do something here. This will ruin the symmetry. Let me throw in that. Okay? So right now, we've got x to the 4th minus 4x squared plus x. And this no longer has y-axis symmetry. You'll notice on the left-hand side, this dips down quite a bit farther than the dip on the right-hand side. Okay, so what's happening here is that this original function is what we call an even function. And if I throw in this x, it's no longer an even function. Okay, so even functions have y-axis symmetry. And the reason they are called even functions is that if your function involves powers of x and all those powers are even, then your graph has that y-axis symmetry. That's not the only way for a graph to have y-axis symmetry. If you do have exclusively even powers, then you have y-axis symmetry. We know a function that doesn't have any powers that has y-axis symmetry, right? Y equals absolute x has y-axis symmetry. So having even powers is not the only way to be an even function. Okay, let me go to the document camera here, and I will pop out for a sec. Whoop. And we'll bring up the document camera, get some good lighting on that thing there. Okay, so even functions have y-axis symmetry if your function has even powers only, then it is an even function. And of course, an even function means this. If this point is on the graph, if a point x comma y is on the graph, then negative x comma y is also on the graph. So the test for an even function is this. The test is f of negative x equal to f of x? If the answer to this question is yes, then you have an even function. Let me title, move that up to the front there. Okay, so that's the question you're going to answer. So you can tell from a function's formula whether or not you have an even function. Let's try this. Is f of x equals, let's do x to the fourth minus 5 x squared plus 7, is that even? Okay, so we'll do the test. We do f of negative x. And this is where the knowledge of function notation that we discussed in the first week of this course comes in handy. Remember, when I first introduced function notation, I encouraged you to replace these x's with blanks. So whatever is in the parentheses on the left-hand side also fills in these blanks on the right-hand side. Now here we've got negative x raised to the fourth power. Now we know the sign rules for multiplying. If you have two negatives and multiply them, you get a positive. Well, here we have four negatives. So that's two pairs of negatives. So all the negatives cancel, and we're left with just plain old x to the fourth. Same thing over here. If we take negative x and square it, that's negative x times negative x, which is positive x squared. Now the negative 5 is just going to hang around, and nothing happened to the plus 7. So notice what we did was we took negative x and plugged that into the function, and we got back the original function. So this function passes the test. It is an even function. All right, let me switch back to Desmos, which was that graphing calculator, and I will show you some stuff there. So let me get rid of the document camera and bring back Desmos, and we know we're doing college algebra. We don't need to see that right now. But oh, what the heck? I'll come back. Okay. So even functions, you're probably thinking, okay, well, there must be something called an odd function, and there is. If I were to write something down like this, x to the third minus x to the third minus 4x, you'll see this does not have y-axis symmetry, but it does have a certain kind of symmetry. You can see this point right here. Well, notice the x and the y coordinate both changed sign. Okay, instead of 1.155, we have negative 1.155. And instead of negative 3.079, we have 3.079. So both of the coordinates change. So it's like the left-hand and right-hand sides of the graph are upside-down versions of each other. Okay? So this graph has what we call origin symmetry. Okay, so odd functions, and I'll bring back the document camera in a sec, but odd functions have origin symmetry. And what that means is, let's bring back that USB camera here. If x comma y is on the graph, then negative x comma negative y is also on the graph. Okay, odd functions have origin symmetry. And a quick way to check is if your function has odd powers only, then you have an odd function. Once again, that's not the only way to be an odd function, but if your function does have exclusively odd powers, then you have an odd function. Let me go back to Desmos here. Oop. Let's get rid of this camera and go to Desmos. Okay, let me show you what I mean here. Let me enter another function like this. We'll do y equals negative x power 3 minus 4 times negative x. Okay, so notice we got the upside down version of the original function. And the test for an odd function is this. Is f of negative x equal to negative f of x? If that's true, then you're dealing with an odd function. And one quick thing to note, there are functions that are neither even nor odd. Okay, it's not like if I give you a function, it has to be either an even function or an odd function. There are functions that are neither even nor odd. For example, this right here. If I were to do f of x equals x cubed plus x squared, and I looked at f of negative x, if I did my test for even or odd, okay, well, I put negative x in to the function, and this function says take your input, raise it to the third power, and then take your input and raise it to the second power, and then add them together. So what I'm doing is I would take negative x cubed, that's 3 negative signs, so the negative would stick around, negative x cubed plus x squared. So this is not equal to f of x because f of x doesn't have a negative out here. And it's not equal to the opposite of f of x because the opposite would have both negatives. Only one of the signs changed. So this is neither even nor odd. So keep that in mind. If your function is even, that is going to help you with your graphing, because all you have to do is plot one side. Same thing with if it's odd. All you have to do is plot the right side, and then you get the left side for free. It's just the upside down version. Okay, so a really helpful idea with graphing, use the symmetry if the function has symmetry. Not every function has symmetry, as we saw right here. This last example, neither even nor odd.